In the video about Harvard and von Neumann architectures, we discussed the methods of connecting the processor to memory and peripherals. In this video, we'll go inside the processor itself. There are two main internal processor architectures, CISC and RISC. CISC stands for Complex Instruction Set Computer, while RISC stands for Reduced Instruction Set Computer. The naming difference can be a little confusing because it treats the instruction set as a complex or reduced. We can find CISC and RISC processors with a similar number of instructions implemented. The difference lies primarily in the complexity of instructions and other features, not just the instruction set. Complex instructions mean that a typical instruction in a CISC processor performs more operations during its execution than a typical RISC instruction. The CISC processors also implement more sophisticated addressing modes. This means that if you want to implement an algorithm, we can use fewer CISC instructions compared to more RISC instructions. Certainly, it comes with a cost. It comes with a price of a more sophisticated construction of a CISC processor than RISC, which influences the average execution time of a single instruction. As a result, the overall execution time can be similar, but in CISC, the processor does more work, while in RISC, the compiler or assembler programmer does more work. The most visible distinguishing features between RISC and CISC architectures to a programmer lie in the general-purpose registers and instruction operands. In CISC, the number of registers is smaller than in RISC. Additionally, they are specialized. It means that not all operations can be performed using any register. For example, in some CISC processors, arithmetic calculations can be done only with the use of a special register called accumulator, while addressing of a table element or using a pointer can be done with the use of a special index or base register. In RISC, almost all registers can be used for any purpose, like mentioned calculations or addressing. In CISC processors, instructions usually have two arguments, where one of them is the source and the second one plays the role of both the source and the destination. In such a situation, the original content of the second argument is replaced with the result of the operation. Let's look at the example. The addition operation of two arguments destroys the original value stored in argument 1, replacing it with the sum of arguments 1 and 2. In many RISC processors, 3 argument instructions are present. In such an approach, 2 arguments are the source and the third one is the destination. Original arguments are preserved and can be used for further calculations. In RISC, the addition operation can have 3 arguments. This modifies argument 1 only, leaving arguments 2 and 3 unmodified. All these features make the RISC architecture more flexible, allowing the programmer or compiler to create code without unnecessary data transfer. The execution units of RISC processors can be simpler in construction, enabling higher operating frequencies and faster program execution. What is interesting is that the modern versions of popular CISC machines, such as Intel and AMD processors used in personal computers, internally translate CISC instructions into RISC microoperations, which are executed by execution units.